we can highlight P position 1. So I want close to the new location instead of the old one. So if you're in front of a robot, right now you're in tool, so we change the coordinator to world. Speed up a little bit, 20%. First, we want move to our right hand side. So that means we have to use the right hand rule. We use positive Y, going to that direction. And because this is the tooling orientation, we want to get roughly rotate to line up with the line. So we want to rotate around X and negative direction. So you will see over here, I have my tooling oriented line up with the destination. Also, I want to go down a little bit. So I think that's good enough to roughly touch up the approach. So Shift, touch up. Set new ID, press No. So we want to have the P1 recorded on here as approach. And now we can go down to the pounce position. So we have the approach P1. Now we want to touch up pounce 1. And we want to jog the pointer close to this corner. So Shift, go to active. So let me zoom in a little bit. So yeah, over here, here's the situation. We can use two coordinate to jog your robot, because you can see almost line up, that's the 45 degree. So if in this situation you change your coordinate to 2 and then you use the positive Z, that will move your robot in this roughly 45 degree close to that corner. So that is what's gonna happen with positive Z. You can see that's in roughly in 45 degree, getting closer to that location. You can see on here. So I don't have to jog in world. If I jog in world, I need zigzag. But with two coordinate, I have this option to line up roughly in 45 degree. So I'm getting closer on here, and in order to move back, we're better to change back to the world coordinate. So now we learned joint, world, and two coordinate. So you need switch between these three coordinates depending on the situation. Like right now, I want to move my pointer back to here, closer to the corner. So it's better set up in world with -X movement. So that's roughly there. Click on the box before rotate, and a little bit more, slow down a little bit, -X. So roughly there, it's good. And go down a little bit. Okay. So yeah, we can look at from here. This is what I mean. So it's not perfect, but we can roughly touch up. So make sure that's on the P2, pounce number 1, Shift, touch up. Record on there. So next we will touch up the starting point, which is on the corner within 3 millimeters, 45 degree. So highlight this line and rotate your robot on this different view. So slow down a little bit, going down. and see here. So sometimes it's really hard to see the distance. So in this situation, it's better to have the measurement set up. So make sure from robot TCP to that corner. So click on that corner. Now we have 10 millimeter distance. All right. So click create dimension. You will have the line, so you can close this window. Zoom in a little bit more. Okay. So we want go down a little bit, and if we want, we can switch back to 2 again. So slow down to 1%. So now the distance is 8.6. We want to have the within 3 millimeters. So that's what we need to do. Use positive Z, jog, and jog it. We have a crash. So now the problem is we're too close to the bottom surface. So we need to jog up a little bit. So that will be the world coordinate. So switch back to world, and even slow down a little bit more, fine, and go to positive direction, that's positive Z. Okay, so maybe go up a little bit more. Okay, so now we can try the 2 again. Go into 2, positive Z. So with the speed, fine. Every time when you press, the robot only jog a little bit, so it will stop. So that's perfect in this situation. You just want to inch in little bit by little bit, right? So now we are getting closer. 6.3. Well, we lose it. So okay, so it's better maybe switch to this angle on here. So zoom in to this corner on here. Okay, I think, yeah, the reason is because we haven't reached to the edge yet, right? So you can see here there's a gap. So what we do is we need to move back a little bit. So that's supposed to be world coordinate. Best way to do it, minus X. Shift, minus X. So inch in there. Let's look at from this angle again. I think that's 2 point something. 2.3 millimeters. Right now we have 2.3, that's within 3. And right, okay. So over here, so you can see it's within 3 millimeters, but the angle is a little bit off because this tooling is too close to the green, the upper side, and we have lots gap between the tooling with the brown box. So we can rotate a little bit. So that means we can rotate around X, that's here, with the negative rotation. So we can try that. Negative rotation. And let's speed up a little bit. 1%. Yeah, you can see the movement on the tooling. It's rotating, it's getting closer to the brown and leave some gap to the jig. So now we want to, you can see this red line is not 45 degrees, right? So we can raise up a little bit. That means the positive X direction. Oh, not positive X. That should be, sorry, positive Z. No, too speed too high. Go to fine and over here. And now we can switch to the, so let's look at where exactly it, okay. Still you can see there's a gap between here. We still need to move back a little bit. So from world minus X, yeah, 1.9. Okay, so that's 1.9, and we can use that as the P3 shift touch up. So we finish the P3. Like I said, because we have this corner as a reference, we can make this position recorded pretty close with 45 degrees and also the distance within 3 millimeters. So now we need retouch up P2 because we only roughly touch up P2. So now it's perfect. We can go back to P2 using the world coordinate to touch up pounce. So what's the requirement? Let's see here. Yeah, so 10 millimeter, right? 10 millimeter as the pounce position, P2. Right, so same thing again over here. It just remind you we're using this. We're using this positive Z point out, negative Z going back. Right, so this is what we're doing. So we have this line 1.9. We highlight P2. The coordinate we need to change to 2 over here and speed up a little bit. We start to go to the minus Z. So when I press this, you will see this tooling will maintain this angle, jog back, then the distance should increase. So we have 8.1 millimeter down. Slow down a little bit. Okay, if you want to get perfect, so 10.2, so you can go in a little bit. I think that's it. So roughly 10 millimeter, that should be good. So now we can touch up pounce 1, P2, shift, touch up. So this is how you touch up the destination and pounce. So if you shift forward, acknowledge that, you will see move from pounce to the destination. Speed up a little bit. Okay, so let's zoom out. Okay, so we got the starting position. Now we need move robot from here to here. So that's the perfect direction with the roll. So we go into roll and we can jog positive X direction. So you can see robot moving to straight line to the destination. If you want, speed up a little bit, closer to the end of the line. Okay, so let's crash. We will find out why. Look at over here. Slow down a little bit. Move back a little bit. Okay. Let's look at here. Okay, it's better to create the measurement line first as a reference. From robot TCP to that corner. So now we have the reading of 7 mm, create dimension line, close line up, 7 mm. Now we need to slow down a little bit. Positive X direction. Here's the crushing point. Where's that? Oh, okay. Let me see. It's not the tooling. I think it's the robot. Yeah, it's the back of the robot on here. So, okay, so this is some rare situation. The tooling didn't crash on the robot tooling didn't crash, but the backside of robot is touching the fixture. So we need to move back robot a little bit, right? So minus X on the wall. Okay, and on this part, what we can do is, because this is too far away from the robot base, and what we can do, we can go into, this is very good situation, we can flip number 5. This is drawing number 5. We can flip number 5 so we can reach further away from the robot. So I'll show you what I mean. So we have the coordinator sent to joint. So if we set up as joint and then number 5, we can use number 5 to jog this part to get the robot further reach. So number 5, we can try this. Yeah, that's exactly what we want to do. So this time I think the crash is because it's getting touch up on the bottom. But over here we are very close to the destination, right? So now we're in joint. So I decide to go further down a little bit, even though there's a crash, so we can have more room on there. It's good. So now we want to switch back to world, because we have the crash with the bottom surface, so we want to jog straight up a little bit. Let's get closer to here. We have distance 6 mm on here, and we are a little bit out on here. So We are in world, we go negative X, getting closer back to okay, it's pretty close on there. So now we're in the situation of the 2 coordinate again. So you can see roughly 45 degree, right? So is it 45? Yeah, it's roughly 45 degree to the corner. We just want to move in, right? So in this situation, it's perfect situation. We switch to the 2. So once we switch to 2, positive Z, and we are closer on there. .1. Okay, I think we have more room with the up, so we can go up a little bit, so get the 45. So shift coordinate to world, and we want to go up, positive Z. Too much. Slow down a little bit. So now roughly, so roughly we have the 45 degree here. So yeah, so you can see this line is almost 45 degree. Then we switch back to 2 again, use positive Z. 2.5 within 3 millimeter. That's good. Okay, so we touch up the ending point. So make sure before you touch up, make sure which line you are highlighting. So now we are still at the starting point. That's not what we want. So we want go down. Then we will have the ending point, line 16, position number 4 highlighted. So 45 degree, 2.5, that's perfect. Touch up. So once we have the ending position, we need to touch up the pounce number 2, which is away from here in the same angle, 45 degree. So highlight position 5, we will start to jog. Right now in 2 coordinate, we don't need to change, we just need to change speed and minus that away from there. 13.9, so we want to get the 10 millimeter. Okay, 9.8, that's close enough. So shift, touch up, pounce number 2. Right. So we finish the touch up. So let's see what happened with the program to run again. So we in step, we take out step, shift forward. Oh, no, but not backward. Okay, so we start from the beginning with 2 lines on there. We can run again. Make sure no crash. Also has that. So the only thing probably is not very good is the approach. So if you step into the approach, so that's something that's not too bad. So it's something, if you want, you can maybe bring in a little bit and to get closer to the destination, so you can go in there, right? So it's up to you if you have this situation. So now we step up here, we step through the program, and you have the measurement line, so we can look at here. So this is pounce 1 with 10 millimeter. Forward again, you will see that 1 point something, 1.3 something, the starting point. Right. So that's what I need to check with you with the dimension line. So if you forward, going to the ending position, getting closer to here, and that's the one we touch up, 2.5 within 3 millimeter, and then if you want you can get it closer, 9.8. So that's the pounce number 2, right? So